who smuggled us into American Studies class. And then after that, we have Dan Westholm, who used to be my junior colleague at the College of St. Scholastica in Duluth, but since I retired 9 years ago, he's now become a senior colleague, or a senior member of the faculty. He's the department chair of the biology department, and he teaches a course on bacterial phage. So he knows a lot of things about that you'll find interesting. And then the third presenter is Jan Peter Verhave, who's a microbiologist who's done work on malaria research, and he wrote a biography of Paul Greif. Okay.
George, thanks everybody. I gotta start just by saying it's my first time here, and I'm loving it. And I appreciate your ears and the chance to speak. If you listened to a college president's address, or a sermon, or perhaps a political stump speech in the early 20th century America, you probably hear something like it. One great menace of the age was the uneducated specialist. Everyone understood the pejorative and its intent, and everyone could draw that cartoon character. It was the engineer without ethics, the doctor without manners, technocrat and mad scientist, that chilly, misshapen expert who knew more and more about less and less. Across the academy, alarm bells rang, and an identity crisis deepened. It was an educational identity crisis, a fracture that formed between the old, shaggy, woolly college, which had dominated the landscape for 150 years or more, and the newer, slicker, rocket-fueled university, where the college tended to its flock, promoting wisdom and culture. The university had different priorities. I'll say more about these priorities shortly, but suffice it to say, the perceived shift was deeply unsettling, existentially threatening to a public increasingly reliant on liberal and general education to create its future leaders. The curricular response was to find some way to inject some of that wholesome college stuff into cold, calculating university. A rehumanizing movement back in the direction of virtue, gentility, culture, breadth, balance, restraint, expansive intelligence, to reassemble the fragmented modern self. So I'll pause here just for a personal aside for context. My own research and teaching in American Studies centers on cultural dynamics of the early 20th century, particularly around what was happening in colleges and universities. Why general education? Why majors? Why core? Why credits? Why 4 years? Why interdisciplinarity? All of these things fascinate me as just things that didn't have to happen, but did. I love doing my research in traditional locations like archives and journals, historical sources, but I also believe in supplementing that when I teach with the feel for the lived aspects of this experience through novels, stories, artifacts, advertisements, fiction. Right? Even slanted satirical fiction makes history more real somehow. So I think where I'm coming from. This is the lens, particularly the educational lens that I kind of bring to reading this novel and others. But it's in those university archive visits or in old issues of Archives and Coolers, very familiar with the pages that you had up on the screen of ads and cartoons and poems. I kept coming across this unredeemable villain who they kept calling the uneducated specialist. Enter Arrowsmith. One could be forgiven for assuming that a novel about a young doctor in search of purpose would bend our sympathies toward the path of this humanitarian hero. And I first picked it up long ago, expecting ingenious amputations and a daring tracheotomy here, nail-biting resuscitation there, episodes of compassionate wisdom, selfless valor, tearful gratitude. But on this, Arrowsmith doesn't really deliver. It does something stranger and far more provocative. There are a few ventures, sure, and Lewis skewers his usual villains, corrupt bureaucrats, stuffed shirts, compromised capitalists. But who's the hero? The novel's deepest admiration is reserved not for swashbuckling health warriors or the compassionate public-spirited reformist, but for a rigid, impatient, prickly specialist, Dr. Max Gottlieb. It was no surprise to find Lewis writing against the grain. I was still struck and fascinated by the real dignity granted Max Gottlieb, especially against this cultural backdrop of pervasive public hand-wringing about uneducated specialists. Gottlieb is wise and well-read, to be sure, but he's not a man of special balance or sympathy. He's difficult, humorless, antisocial. He avoids institutions, snubs publicity, dismisses public health crusaders as self-congratulatory panderers and carnival workers and frauds. For these reasons, Lewis treats Gottlieb with reverence. He's flawed, but in my reading, he remains the novel's moral center. It's a crazy thing to say about a character who advises Markham to not stop the catastrophic suffering in St. Hubert's in order to preserve an experiment's control and to get accurate data. But this essay explores Sinclair Lewis's iconoclastic stance in Arrowsmith and how the novel challenges dominant cultural and educational narratives about specialization. Rather than reinforcing the ideal of the well-rounded or integrated thinker, Lewis projects a profound ambivalence. Instead, we get an admiring portrait of a specialist, not in spite of his self-imposed limitations, but because of them. What emerges is a character study that rejects well-worn educational cliches of the time, and frankly ours too. For those of us who study or shape curriculum who care about expertise, Lewis's vision is both sobering and electric. As I mentioned, I work on the history of college curriculum. I've explored the emergence of general education and interdisciplinary in the American university. Over-specialization is easy to identify as the evil, and the uneducated specialist, the villain. But who was the hero then? What was its origin story? All heroes have an origin story. So that story goes a little something like this. At the turn of the 20th century, rapid changes in society, economic, scientific, industrial, philosophical, had converged, giving rise to a new kind of workplace, newly concentrated urban centers, new kind of commercial market. But arguably the most impressive monument to this new spirit was the American university, with explicit ambitions for progress discovery. Universities were wildly different institutions than the humanistic colleges that preceded them, and were taking over as the dominant model of higher education in America. I'm intentionally speaking in exaggerated types here, using well-established conversational shorthand, that they also gendered shorthand, apologies, of college man versus university man. These are recognizable caricatures in common parlance. College man personified sophisticated taste and genteel wholesomeness, if also a somewhat leisurely disposition. University man wielded a more trained seriousness, ambition, and accomplishment, but little else. And this was a widening gulf between the two types in the early century. Disciplinary specialization was a distinctive feature of the modern university, and the catalyst of its growth. New universities like Chicago, Hopkins, Clark, Stanford, along with other colleges, Columbia, Harvard, Yale, who saw the writing on the wall, organized or reorganized around academic disciplines to pursue expertise and specialization above all else. These were heady times for knowledge, boast, and invention. The old college, was once the proud purveyor of broad knowledge, classical languages, rhetoric and eloquence, philosophy and the arts, perhaps a smattering of math and science. They were places for teaching. Schooling here cultivated character through ordered intellectual exercise. History, philosophy, ethics, literature, they did not appear as discrete disciplines, but as chummy chunks of a whole. And that amounted to wisdom. Students would emerge with a broad, liberal education, not with expertise in anything in particular, but with cultivated sensibility, trained taste, and the kind of refinement we look to for leadership. The university, in contrast, answered a different call. Not interested in finishing gentlemen anymore. Universities became engines of industry and progress. Students were passing through for credentials, training, promises of prosperity. And while the university excelled in research and scholarship, it seemed uninterested in nurturing character, proportion, gentility. As traditionalists would tell the story, the university's abandonment of the classical curriculum and replacing it with electives and specializations constituted a raw deal for the soul. The rise of professionalism in the university further accelerated the specialist trend in academic disciplines was that catalyst. Shared knowledge gave way to exclusive expertise, where disciplinary specialists use tools and language that non-specialists can't access. And these fences keep quacks and hucksters out, which is good. It's important for professional expertise in the form of degrees and licenses and credentials and certificates. But those fences also isolate the specialist away from the general public with an arcane language to really seal the deal. In the early 20th century, that knowledge that supposedly mattered most then was siloed, territorial, exclusive. General knowledge, on the other hand, was for dilettantes and dabblers and the Chautauqua circuit. Specialties became subspecialties and fragmentation worsens. The uneducated specialists, in other words, were proliferating, producing vacuums and zippers and cures and equations, but was anyone tending to wisdom anymore? So it wasn't selfishness or aloofness that led to this rush to specialize. The professions actually grew to demand it. Academic specialization is merely an episode in the history of the division of labor. On an assembly line, one worker sets the wheelbase and the next screws in the rivets. In an English department, one professor sets the Shakespeare and the next screws in the joists. Though otherwise hard to compare, in both cases the world shrinks. In the early 20th century, that new academy, just like the new economy, demanded speedy proficiency from its workers in a single discrete area, rather than middling proficiency across several. So, specialization made a lot of sense as an organizing principle in the university. It understood the real power of the profession, of the academic discipline, and self-policing machinery, of academic freedom, and the pure pursuit of knowledge. But the public was still sentimental about the college ideal. They were worried. Newspapers and philanthropists and presidents abetted those worries, crowing about uneducated specialists, and the counter movement that emerged was general education. Gen Ed programs were direct responses to the perceived crisis of narrowness, human narrowness, the specialist who could ace the test but could not survive the conversation. This narrowness, crucially, was not a lack of education. In other words, the uneducated part of the pejorative was always factually incorrect. But it was education out of balance. Specialists were not undertrained, they were over-siloed. They'd been fed knowledge in deep but isolated wells. The result was a generation of Americans who could engineer a bridge or develop a drug, but who could not, in the words of the reformers, live wisely and well. Again, these are cartoons. These are probably not truths, but this is the national narrative that we were fed in the early 20th century. there was real concerns that our minds themselves were being maimed by this kind of hyper-focus, by a reward structure that increasingly favored the sharpening of knowledge over its connection and application. In 1908, Irving Babbitt, no relation, said, the work, maybe that connection actually. He said that the work that leads to a doctor's degree is a constant temptation to sacrifice one's growth as a man to one's growth as a specialist. We must be men before being entomologists. I confess I love that line. I do. The narrowness problem began to feel existential though. In response, gen ed programs emphasize the big questions: ethical reasoning, shared knowledge, culture, cross-disciplinary fluency. And it had the posture of a moral project. The idea was to make specialists human again, to ground knowledge in ethics, to connect it to civic life, and to keep expertise from floating free of conscience. The lab technician must read Plato. The economist must grapple with history. The med student must understand suffering as well as science. The curriculum, in short, had to rescue and restore the soul of the student. So when Lewis published Arrowsmith, it entered a world already buzzing with reform and redirection to thwart that specialist barbarian. With Dr. Max Gottlieb, however, Lewis lurches in the wrong direction, giving us a specialist not in need of fixing, but a kind of secular saint. Arrowsmith flips the script. So this specialist was a villain familiar well beyond the academy. By the early 20th century, literature and film was brimming with figures who embodied the dangers of knowledge unmoored from the heart, of intellect divorced from wisdom. The mad scientist, the brilliant loner, the hyper-competent misanthrope. These were characters not new in the 1920s at all, but they were gaining cultural velocity, and they were always dangerous. Frankenstein, Moreau, Jekyll, Faust, every Spider-Man villain, HAL 9000. Intellect without heart is not just sad, it's catastrophe, and that's the message. So what does Lewis do with the archetype? At first glance, it seems Max Gottlieb fits the mold. He's isolated, uncompromising, mean, emotionally opaque, almost fanatical in his devotion to scientific purity. I consider the movie almost transcendent. He dismisses publicity and politeness. He holds jolly college presidents and institute directors in scorn. He distrusts institutions, turns down fame, money, and comfort in favor of an obsessive hermetic search into the unknown. He even opines at one point about whether a deadly virus has more right to live than humans. And he is, by any measure, deeply difficult. A man who sacrifices relationships, reputation, and even health in service of his calling. But he's not presented as a madman. Gottlieb doesn't destroy the world. We worry about his balance in humanity, but his refusal to compromise with business, reputation, politics, that is his heroism. On the other hand, the characters Lewis skewers so viciously are those who do compromise, who sell, who climb institutional ladders, and cater to public taste. But those are also those who arguably see the big picture, care about humanity, know how to navigate complexity to get things done. That's the vexing trade-off that this novel acknowledges. Gottlieb may be rigid, but he's also incorruptible. And in Lewis's moral calculus, that seems to count for more than charm, breadth, or social utility. Gottlieb's specialization is his moral compass, his freedom from corruption, and his inscrutable soul. By elevating Gottlieb rather than pathologizing him, Lewis overturns a powerful cultural script. Those who sell, powerful cultural, I knew it was a page. Sorry. This isn't just a literary provocation, it's a philosophical and professional one, and it throws the still ubiquitous generalist project into uncomfortable relief. In the world of Arrowsmith, science is constantly under threat, not from ignorance or error, but from compromise. Lewis doesn't fear the specialist who knows too much, nor one who knows things too narrowly. He fears the administrator who cares too little about fact, too much about prestige. Holabird, the polished master of committees, is everything Gottlieb is not. Charming, strategic, career savvy. Holabird doesn't oppose science, far from it. He champions it, funds it, promotes it. He works donors, motivates the research, popularizes in practical ways, advances the cause. Remove Lewis's satiric edge, and Holabird is exactly the kind of figure that general education often holds up as ideal. Someone who bridges disciplines, translates knowledge into public impact, and ensures that research is relevant. And there's a lot to admire in Holabird, or in Pickerball, the blustery designer of weeks. One of the joys of reading Sinclair Lewis, for me, is realizing that I'm nodding and cheering as he takes down people I actually admire. But in Arrowsmith, these are shallow manipulators, fluent in Babbitt-esque administrative dialect and well-practiced congeniality and collegiality. Pickerball doesn't lie, he just dulls the sharp edges of truth until science becomes palatable, presentable, and profitable. Holabird speaks the language of collaboration and progress, but underneath it lies a hunger for relevance and power. Gottlieb sees through it all. He warns Martin again and again not to seek admiration, not to court applause, not to become a popularizer of science. One of his most devastating lines, a perfect distillation of his ethos. If you want the praise of the world, go be a tailor. If you want the truth, be a scientist. That disdain for public approval, for anything outside of the narrow pursuit of knowledge, is what sets Gottlieb apart. It's also what makes him immune to the very pressures that institutions, foundations, and universities routinely apply to their scientists. In a world of compromised people, that resistance begins to look a lot like virtue. In Gottlieb, Lewis offers a vision of intellectual dignity that refuses to be softened or well-rounded, that does not do science in context. He wants science that is true, regardless of who it helps, how it's received, or whether it comes to profit. First, last, all the time. This may not seem public-spirited, but it is an ethical position, even in its absolutism. And it stands in sharp contrast to the vision of the college or university as a place of integration and stability. It's not that Gottlieb hates humanity or celebrates disease. He's just a purist about the knowledge economy's division of labor. The scientist must doggedly pursue fact, truth, precision, independent of its consequences. This is what we rely on him for. It's the next person, once the science is ready, who takes it and shapes it to some vision of social purpose, of promotion, public good. And this is where Lewis turns the educational narrative upside down. In most institutional storytelling, then and now, the press-savvy integrators are heroes. Robert Maynard Hutchins, chief among them, was a handsome Holabird from Central Casting. In Arrowsmith, they were the villains. So Eric Martin himself was caught between these two visions, the purity of Gottlieb and the polish of Holabird. He wants to believe science is a calling, but he also wants recognition, comfort, and salary, love, and success. He wants to help. How dare he? He's torn. He bounces between labs and clinics, between private research and public health. He's drawn to Gottlieb's severe clarity, but constantly pulled toward the seductive smoother path of influence, applause, and salary. In St. Hubert's, he's there to help, tries to follow Gottlieb's strict, cold-eyed method, and do where it dies. So is this Lewis's answer to the question of integration? That science and its application must naturally be in conflict? Is Is that what Loyora's death means? That Martin either chose wrong or that he fatally erred in choosing at all? I admit that my answer is a hopeful hedge, yes and no. I'm deeply appreciative and entertained by the dignity restored to specialization through godly, a pure, unapologetic truth seeker. But I actually don't think that Arrowsmith's answer is that science and its uses, or science and humanity, are irreconcilable. They're just different. We need a division of labor, maybe an epistemic division of labor. The world needs all kinds. Science doesn't need to become more humane to be valid. It can't. Likability or kindliness isn't the test to which we should reject science. And on the flip side, humanity, or the humanities, don't need to become more technical to be relevant or meaningful. Again, it's the wrong test. We read and we listen and we love in search of meaning, not precision. Lewis is always very easy virtue. And there's a temptation in believing that broad-mindedness is always superior, that integration is always healing, that compromise always delivers. He doesn't reject those ideas outright, nor do I. But the dilemma that divides Martin's heart and propels the story is the tension between pure science and its humanitarian application. Lewis poses hard questions about popular platitudes that inform our systems. Are the well-rounded really better than the deeply focused? Are the polite really more virtuous than the difficult? And is the kind of education that produces people of integrity the same as that which produces versatility, cocktail party prowess, persuasion? Even today, our culture remains suspicious of the specialist, and we shouldn't dismiss or denigrate prickly doctrines in the process. What hides under this prickly rigidity is dignity, heroism, and truth. We can't live without them, and we just need to get out of their way. It's an uncomfortable notion for me, a believer in a designer of general education, but it feels worthy of our attention in 2025. Thank you.
So is that going to be me?
Just displaying this. Maybe I just need to go back.
You didn't guys say anything else? That's on there.
Thank you. All right. So thank you all for being willing to sit through a biology lesson here. My name is Dan Westholm. I am a professor
professor in the biology department at the College of St. Scholastica in Minnesota. And as George mentioned, we were colleagues for quite some time. And so I'm going to present some of my thoughts on Arrowsmith from a biologist's perspective, and also how I use this novel in one of my courses that I teach. And if you notice, a lot of my slides with the Science Education Alliance, my bacteriophage courses that I teach are part of the Science Education Alliance, where we isolate, purify, and characterize bacteriophages as part of a global research project. Okay, so I'm going to cover a variety of different topics today. I'll begin with just a brief overview of what bacteriophages are. And I get the question a lot, is it phage or phage? Either is fine. A lot of the people that I work with kind of introduced me to this field using the term phage, so that's what I use. And then I will talk a little bit about how I got into bacteriophage biology. And then I'll do an interpretation of the microbiology presented in the book, and then how I use it in the classroom. And hopefully, if time allows, I'll go over a fascinating modern phage therapy story that some of my work was kind of aligned with. So I'll start out with this. So what are bacteriophages? So bacteriophages, this name makes it sound like there's something real specialized about them, but they're just simply a virus that infects bacteria. So for all cell types on planet, from human cells to plant cells, bacterial cells, there are viruses that can infect them. And so a bacteriophage is just a specialized type of virus that can infect bacterial cells. Viruses are obligate parasites, meaning that they have to infect another cell in order to replicate. So they can't grow just free living on our skin. They can't grow by themselves on a petri dish. They have to infect a cell. And so in this picture right here, we're looking at some staphylococci bacteria in pink, and those kind of gold balloon-shaped things are phages that are attaching to the surface of the cell, beginning the infection process. So what is really unique about bacteriophages compared to, say, a virus that infects a human cell is their abundance and diversity. It wasn't known until relatively recently, probably about 30 years ago or so, that phages are absolutely everywhere, and the numbers are just astounding. So in Arrowsmith's day, phages were known as something. Exactly what they were wasn't quite identified, but it was not known for decades after that just how abundant these things are. So they completely are kind of transforming bacterial life on this planet on a constant basis. So what happens when these viruses find a cell that they can infect? They begin by attaching to the cell wall, that's the covering of the cell, and they need to find a way to inject their nucleic acid into that cell. So a phage, like any virus, is basically just a protein shell that is protecting its genome, usually made of DNA. And so in this picture, we see these are the phages here. This is the cell wall of a bacterium. And we can see that they're kind of in different stages. This one kind of looks like it's contracted a little bit. That's helping it to digest its way through that cell wall and inject the DNA that contains instructions to make new phages into that cell. All right, so that's step one. Now, once those instructions get into the cell, all sorts of bad things usually happen to that cell because they contain instructions to make new phages. So many that that cell will probably blow up and die. And so that's what we have shown right here. This is an E. coli cell, the remnants of it right here. And it's been lysed, it's been burst open by all of these phages that have been produced inside of it. So it only takes one phage. You can see on this picture we have lots of phages surrounding the surface of this. It only takes one to start that infection. And those instructions for that one phage can be copied into a whole bunch of them. And so in the phage therapy in Arrowsmith, this is what the scientists are hoping for, the physicians are hoping for. That the bacteria that are causing bubonic plague are going to be infected and then destroyed. And because phages are so specific, in most cases, they aren't going to do anything to our cells. Even though they have to have a cell to infect, they don't infect and harm human cells. So, this slide shows the two fates of this infection. With phage therapy, we want to have a phage that does this. It's a lytic phage. It's going to attach to the cell, it infects it, that cell follows the instructions to make new phages, and the cell dies. That's the only fate of that infection. It's lysis, cell bursting. But it turns out most phages, and this was unknown in the time period of Arrowsmith, most phages actually go through this different life cycle. And this created problems with early phage therapy because this was not known. A lot of phages are temperate. They'll infect, but they don't actually kill, or at least immediately kill, their host. They can go through a cycle called the lysogenic cycle, where the DNA, the genome on that phage, instead inserts itself into the bacterial genome. And so now this bacterium is called a lysogen. It's infected with the phage, but it survives. And that bacterium can grow and divide, and kind of copy that virus genome for many generations. It's a stable interaction. But if that cell gets stressed, the phage can detect that and can say, I'm getting out of here. And it will leave this cycle, the lysogenic cycle, and enter the lytic cycle and kill the host before the host dies. So a pretty remarkable situation here. This was unknown in Arrowsmith. But when we were watching that movie last night, it occurred to me there's actually a unique link to phages, actually in a harmful way, with a diphtheria case. So when the child died of diphtheria, so usually a respiratory infection, the bacteria that cause diphtheria only become really pathogenic if they're infected with a phage. And the phage, so it's a phage that goes into this lysogenic cycle, it expresses a toxin that causes the severe symptoms of diphtheria. So there's actually two kind of involvements of phage in Arrowsmith. The diphtheria case, which actually ended up killing someone because of a phage, which is unusual, but it happens. Same thing with cholera. The bacteria that cause severe cases of cholera are infected with a phage. They have this prophage. And then also phages are used beneficially to treat bubonic plague. All right, so how do we know we're working with phages? Phages are actually, one reason why they're so difficult to characterize, and there's debate as to what they were, is because you can't see them with a typical microscope. So the microscope that Dr. Arrowsmith used in the movie that we watched last night, phages are invisible to that type of microscope. You cannot see them, they're way too small. So how do we even know that we're working with them? Usually what we're looking for are plaques. That's what we see on this petri dish right here. This thin kind of beige film here, that's a bacterial lawn. So this could be the Yersinia pestis bacteria that causes the plague. It could be another species that's covering the whole surface of that plate. But if we have phages that can infect them, they will start to infect and kill those bacteria, creating a clear zone called a plaque. And so that's how we know we've harvested phage. In the movie and the book, that initial isolation and identity of phage is through liquid culture, which we can use, but typically we're using solid cultures, bacteria growing on a plate to see phages without a microscope. Today, and it wasn't until probably like about 1940, we now can see phages. 1940 electron microscope was developed, and phages were visualized for the first time. And so we could actually see that they indeed were a unique life form. They weren't an enzyme or something, because again, that was debate in the 1920s, both in real life and in the book. What are these things? Are they a unique life form? Are they some toxin? Are they an enzyme? They're a life form. Okay, so why do we care about phages today? Well, we know about phage therapy, right? So that's obviously a really interesting thing. That really interests my students, it interests me, so it's a natural connection that we have. We know bacterial infection can be very severe. Here we have something other than antibiotics that can help us with the antibiotic resistance crisis, that can help treat bacterial infections. But as I mentioned, phages are so abundant. 10 to the 31 estimated viral particles, phage particles. Most of them are in places like the dirt, soil, ocean, but also in us, on us. They are everywhere. They're in the air that we breathe. Phages go throughout our bodies. They're not just in our digestive system, they can go through our tissues. They've even been found in the human brain. So places where you think would be sterile actually have phages in them. Even though they aren't infecting us, they are with us. And they're constantly infecting, though, their hosts, which are bacteria. So the other reason why they're really interesting, they're super genetically diverse. Lots and lots of different phages infecting different bacteria. And so there's this untapped reservoir of genetic information we just discovered. And so that brings me to how I got involved with phages. So in graduate school, I studied as more of a biochemist, molecular biologist. Those fields didn't really exist too much in Arrowsmith's day, they were in their infancy. But when I got my job at St. Scholastica, I got involved with the C-Phages program. It stands for Science Education Alliance Phage Hunters Advancing Genomic and Evolutionary Sciences. Kind of cool. But it's basically an international community of researchers, kind of a crowdsourcing effort to characterize this enormous group of phages that shares the planet with us. So there's over 200 colleges and universities participating in this, where we're trying to isolate phages from the environment and learn about them. So the basic way that we find phages is we start with probably one of the best places to begin to find phages is soil. So a single teaspoon of soil, it's kind of one of these mind-boggling facts, 1 billion phages. We went right outside this building, we get a little spoonful of dirt, there's probably 1 billion or more phages in there. And so you're probably going to find a phage, even for the single species of bacteria that we're working with. So we mix them with our host, which is called Mycobacterium smegmatis. You've ever heard of E. coli or Salmonella bacteria? This is just another species of bacteria. Then we look for the plaques that I talked about. Then we purify it into a lysate. And this is what, in Arrowsmith, this is what was being injected into the patients, this lysate. This is basically a fluid of phages that you harvest after they've infected the bacteria. Then we can stain them and look at them under a microscope. This Arrowsmith could not do. And then we isolate their genomic DNA. And this is another thing that Arrowsmith couldn't do. We can characterize that DNA, we sequence it. This is the first semester of the C-Phages course. And then the second semester, we do some comparative genomics to learn about the genes and the genomes of these phages. So as I mentioned, we're not doing this alone. This is now a global effort. So Arrowsmith kind of working within his research group and being in competition, hearing about Durrell and Twort and all these other people and being devastated by that news. Now science is much more collaborative. There still is this worry about being scooped, having someone publish something or identify something before you have a chance to publish it, but this is a highly, highly collaborative research project. And so all of our data is shared on this website called PhagesDB, and you can see there have been almost 30,000 phages isolated, unique phages isolated by students across the world, including mine. And then about over 5,000 have had their genomes sequenced. And again, this was not possible in Arrowsmith's day. They didn't even know what coded for genes. DNA was known as a molecule. What it was thought just be kind of boring sugar type molecule. It's pretty remarkable. This shows where these phages have been isolated from on a global scale. This is not all phages. These are just phages as part of this program that I'm involved with. And most of the colleges and universities are located in the United States, but also in Canada, some parts in South America, Africa, Europe, Asia, and Australia. So really it's turned into a global effort. So just briefly, I teach this as a 2-credit course where we isolate the phages, characterize them in that wet bench. This is much more, that wet bench lab, this is much more similar to what Arrowsmith was doing. We're working with many classical microbiology techniques. And then in the second semester, this is computer-based bioinformatics work. This is these two pictures here, these are my students working on with a dissecting scope to prepare grids for the electron microscope to look at their phages at Mayo Clinic in Rochester. So this is what we would produce after a semester's worth of work. So each student has their own phage. We get plaque pictures, we do some DNA analysis here. You'll notice that there are these names like Venti or Briar, Tokyo Drift. These are the phage names. Students can name them. The general They don't have a Latin name like the Linnaean classification. The basic rules are, like, kind of think about this as how you name a pet. Something that, and I think that's how a lot of students take it. The number one rule, though, this was not for me, this is from the principal investigators lab at the University of Pittsburgh. The number one rule is the Phage name cannot rhyme with or include Nicolas Cage. There was one time Nicolas Cage, Nicolas Phage. All right, so anyways, these are a couple of my favorite pictures from just recently. So phages generally have these three different morphologies. We have cyphoviruses, which kind of look like these balloons. Myoviruses, which look like kind of like I always think they look like a robot or some sort of spacecraft that's landing on the moon. And then the potovirus, which have these short little tails. With Arrowsmith's phages, again, he couldn't see them. They were probably a mixture, or one of these two types, the cyphovirus and myovirus. This was a kind of unique myovirus that we saw a few years ago that has this really long tail with this big sheath. This is a more typical myovirus with this contractile tail, but a much shorter length. The vast majority of phages, though, have this, that we isolate at least, have these long, flexible tails. So they look like a balloon. This one's been colorized. And one interesting thing, there's a lot of accidents in science. This picture is one of my favorite pictures. And it was a contaminant on tweezers, on forceps that we left in the lab at Mayo Clinic after we stained our phages. And the scientists there used the same forceps as us. They're looking at human tissues, kept seeing phage, like, oh, I know where that came from. And the scientists at Mayo, they sent us this colorized holiday greeting card with our phage. Yeah, so that was the name. That's a population of little munchkin phages. They are all genetically identical. They all have the same genomes. So the name is little munchkin. Yeah, I like that name. There are other names where it's hard. They don't. You kind of wonder what is the meaning behind this name? Should I? Yeah. Anyways, okay. Now on to Arrowsmith and how you've kind of seen how I'm working with phages classroom. How my questions are: how close is the microbiology approaches, the phage biology, phage therapy produced in the book to what is done today? And then also, how can students in 2025 find utility in this novel? Okay, let's start with the microbiology. So a lot of the classical microbiology, I like this. I really love classical microbiology because there's some timeless techniques. So a lot of what was presented in the book still is done today. So let's think about media preparation. So pouring those petri dishes. This is a quote from the book. Students were filtering nutrient gelatin, their fingers gummed with crinkly gelatin leaves, heating media in an autoclave like a silver howitzer, roaring Bunsen burners, to Martin, the most radiant things in the world were rows of test tubes filled with water, serum filled with cotton, fine platinum loops, bottles of Genetian violet, otherwise known as crystal violet in most cases. So all of those things are still used today. Usually we're using powdered agar, but we still can use gelatin. And even in Arrowsmith's day, they use agar. It solidifies better than gelatin. It stays solid at incubation temperatures. We still use autoclaves. They still make lots of noises. They are like silver howitzers. Bunsen burners make a lot of noise. Still, we use inoculated loops. Sometimes they can be platinum. Usually they're made out of something else, another metal. This is a quote from Max Gottlieb. Again, totally relevant to today. The most important part of experimentation is not doing the experiment, but making notes, very accurate notes, quantitative notes in ink. I'm told that a great many clever people feel they can keep notes in their heads, and that's always the great temptation with students, and even I feel it from time to time. Like, I'm going to remember that. I don't need to write it down. Yes, you do. You have to write it down. You will forget. And so Gottlieb goes on to say, I've often observed with pleasure that such persons do not have heads in which to keep their notes. This is very good because the world never sees their results, and science is not encumbered by that. Some things that were less familiar. So in medical school, when that's portrayed in the novel, they have first-year students. infecting guinea pigs with Bacillus anthracis. This is a biosafety level 3 microbe that would not be used by first-year students. There's really no mention of biosafety level or personal protective equipment. Saw in the video they're throwing things in a kitchen sink and trying to clean them there. But overall, things are presented very accurately, and I'll talk a little bit more about that in a minute. And the only kind of glaring exceptions that I saw with accuracy are understandable based on the limitations of the day. So first is that Martin's mentor, Gottlieb, produces antibodies in vitro. That means in a test tube. That was totally impossible and decades away from that happening when this was written. It took the advent of cell culture, which is a sophisticated technique that first arrived in the 50s and 60s and still is being refined today. And another thing, this is contradicted actually in the novel, but at some point it says Martin propagates phage on dead bacteria. And again, they didn't know anything about phage life cycles then. They didn't have any real good ways to study what happens to a phage when it infects with bacteria. And is it even an entity, a biological entity? And phage can only infect living bacteria. Dead bacteria isn't going to serve as a suitable host. Now, something that my students really can identify with is when Martin Arrowsmith identifies phages. That's kind of this aha moment that my students can share. Yeah. So he's working on Staphylococcus from an infection that was on a patient that was healing unusually fast. So they cultured the pus in a flask, developed some cloudiness. So as when bacteria grow, they stay suspended in liquid. It looks kind of cloudy, it looks like milk. And then when they returned to the incubator, they found the surprise. The flask, in which there should have been a perceptible cloudy growth, had no signs of any bacteria. This is clear as when I seeded it. And so the bacteria had been killed, they'd been lysed, and then they fall out of solution, the solution gets clear. And on the movie last night, it looked like it was crystal clear, it looked like water that was poured in the flask. It wouldn't look like that. It would still be, it would have a color to it. The media is usually a yellowish or orangish color. It still would have that color. But some of that cloudiness will go away. And so they didn't have the benefit of electron microscope. A lot of the descriptions are remarkably accurate, but they're limited. There was this uncertainty. Is this a chemical? Or is it a new type of microbe, a germ? They eventually called it the phage, the X principle and the phage. And all these things in quotes are totally true today. So they can be transmitted indefinitely. So you start with one phage and you can just keep growing the phage over and over and over again. And they don't propagate on dead bacteria. And then again, as mentioned later on, you figured out a way to do that. They call them bugs that live on bugs. So viruses are a type of microbe that lives on another type of microbe. This one is really insightful, blundered into the effect of phage and mutation of the bacterial species. So that was really remarkable. That we see today with coevolution. The phage will, the bacterial host will adapt to the phage and fight back against the infection, and the phage will have mutations that can fight back against those new mutations, this constant dance between the two. We added a drop of the principle to a growth of Staphylococcus, which is a gray film, which we call a lawn, and the drop was beautifully outlined by berry patches as the enemy evaded its attack. Okay, how much time do I have? I'll make it short. Okay, so we know how what's happening here. The phage therapy trial that Martin undertakes, and he's determined to be scientific, have this randomized controlled trial, and we know this is controversial. And initially, at least when I was reading this book, I thought that he was going to be just treating sick people who were already infected. But then he approaches it more like a vaccine, giving it prophylactically. And again, we saw that in the movie last night where people are lining up and getting, who aren't even ill yet, or are getting injected. So it's more like a vaccine model. So this control group, this is a great controversy. Even today, bioethicists are not in agreement with this. So some researchers argue that it is ethical to use a randomized controlled trial setup if there's genuine clinical equipoise. So there's uncertainty whether or not this is going to do any good. If there's no other treatment that exists, we have this new thing, it might work, but we really don't know, then it's probably okay. Others don't think, even in those situations like Dr. Porter's, that this is ethical. some comparable situations that we can kind of use with St. Hubert's outbreak. We have situations with the West African Ebola outbreak and Democratic Republic of Congo outbreaks where new vaccines were developed against Ebola that were tested. And in many cases, they had either a control group or modified control group in those situations. And then, obviously, with the 2021 COVID vaccine rollout, so they're more available in 2020, but 2021 they started to be trialed. There were control groups, and then there was controversy as data started to be coming in that these vaccines had efficacy. At what point do we stop having control groups where we know these things actually are giving some benefit? Now today, let's say we're going to start a phage therapy trial, and how could we set up a double-blind randomized control trial? There are problems even today outside of the ethical ramifications. So first off, when we're testing a new medication, we want that medication to be exactly the same from person to person. Well, with phages, that's almost impossible. You need customized cocktails that will work against the particular strain of bacteria that's infecting patient A, and another one probably for patient B, even if they have the same infection. Phages are that specific and picky sometimes. You can have variations in immune response. If you inject phages into someone, sometimes the immune system will respond to it. And then we have a self-replicating medicine, so you don't know how much did someone actually get. And a phase 1 safety trial where you give them to healthy individuals, that's problematic because if you have someone healthy, they don't have the host for the phage, so you don't know what the phage is going to do. The bacteria aren't in there. And then lastly, there's a lot of this in Arrowsmith, a lot of the intersection of the commercialization of medicine. Well, phages are natural products, and if you don't modify them, you can't patent them. They exist in nature. And so making money off them, encouraging pharmaceutical companies to invest in their development can be problematic. And one of the last things I'm going to talk about with respect to the science here is that will this even work? This prophylactic use of phages. And there's all sorts of evidence that yes, it will. So prophylactic means so the patient isn't even sick, you give them phages and that prevents them from getting sick from the vaccine. And there's support for this in various animal models. That's what I have the in vivo brackets there. And then even ex vivo, where you use phages in the environment to try to kill, say, this was done really in 1927, so a long time ago, to prevent a cholera outbreak. Find the water source, dump a bunch of phage in the water source, see if it prevents cholera. Some evidence that actually worked. There was a trial in India that Raalte oversaw. And again, there's controversy over the control group. Should they have a control group? And then at that time you could buy phages, and people started, even in the control group, they found phages. They started dumping their own phages and screwing up the experimental design. I'm going to skip through this. I just want a couple of last final thoughts. So George we were on the curriculum committee. He was the chair of the curriculum committee, and I presented a phage course through the committee to be accepted as a permanent course. He's like, "Oh, phage, have you read Arrowsmith?" And I said, "Well, I had to admit, I had not. I had heard of it. I'd heard of Sinclair Lewis. I didn't know those two things overlapped." But I had heard of the book, and I knew it was about phage therapy. And he encouraged me to read it. And so I loved it. I've incorporated it in my course, and then together with George's help, along with some other colleagues in the CPhages program, we made a CUBES resource, which provides teaching resources on introducing Arrowsmith into the classroom, slides for background on Lewis, background on the book, and you can see this was we now have 1,000 views and 718 downloads from this resource, so I think that's pretty cool. And then we also have to tell them, I'm introducing this to the students, that this is a book about phage therapy, not about the parent. That's becoming less necessary as time goes on. They've never heard of either of ours. These are some things. So we don't read in my class. We don't read the entire novel. It's a 2-credit class. We're doing mostly other science activities, but I do assign several chapters. Again, with the McGurk Institute part, and then the phage therapy part, where we do a lot of we have discussions and other activities associated with them. Very, very quickly. Do I have 1 minute? So this is just a really cool story. So we hear about phage therapy trials in Arrowsmith. Are they still being done today? Yes, they are. In Georgia, the country Georgia, and Poland and other former Soviet bloc countries, phage therapy kind of never went away, and it is more established. In the United States and in other parts of the world, phage therapy is largely forgotten and abandoned because antibiotics are so much easier. But sometimes antibiotics don't work, and so this is a case where it didn't. This is Isabel Holdaway, who had cystic fibrosis and had a completely antibiotic-resistant infection. She was sent home to die because there was nothing else that could be done. Enter phage therapy. So at a conference for phage therapy, this physician, Alan Spencer, who was working with Isabel, met with Graham Hatfull, who's the principal investigator of the C-Phages program, and asked, is there anything that we can do? Can we try phage therapy? There's no other options for this patient. And so they said, well, we can try. And so we had that. There is now a freezer that has 20,000 different phages, and 28,000, and they were tested. They got a sample of the bacteria that was causing the infection, and they tested all and thousands of bacteria to see if they would infect this particular species in this patient. So this was Mycobacterium abscessus. That's the bacterial infection. We isolate phages off Mycobacterium speculans, so relative to this. And 3 phages were found that could infect this species of bacteria affecting Isabel. And we can see her lung function is terrible. She gets a lung transplant, it helps a little bit, it's still not great. She gets phage therapy, it goes way up. We can see the skin lesions. Here's pre-phage therapy. We can see lesions on her abdomen and her arms that began to heal. Infections that were spreading throughout her body also dramatically were reduced. And so she survived for several years after this, and then unfortunately she passed away about a year ago due to other complications from cystic fibrosis. But she had years added to her life. So, sorry. So, with respect to our phages, we had a close call in this particular case with this phage T117, which was tested for activity during this whole search for phages. And one of ours ended up actually being mentioned in this Nature Medicine paper, and perhaps could have some utility in phage therapy. So relative of I think it's BGS right there. So, pretty cool. We had a close call. And then it continues to be used. So that wasn't just a one-off case. There have been about a dozen or so cases or more from the phage therapy from the C-Phages program. So takeaway, the book remains inspiring, accurate, pretty impressive, 100-year anniversary. Cutting edge science at the time, must have seemed like science fiction, and remains really kind of a source of inspiration to students in the 2020s. So, all right. That's it.
Well, ladies and gentlemen, welcome, Sally. Thank you very much for the invitation to present some thoughts about Arrowsmith. Pulitzer-Prize, the microbiologist, supplied Lewis with so many invaluable details on student life in Ann Arbor, laboratory practice, various medical men at the New York Rockefeller Institute for Medical Research, that one can say the book cannot have been written without Paul the Crier. The two men were a synergy of talents. I was able to reveal some details about the characters of the book that Paul veiled for decades. One example, not about a character, but about the McGurk Institute. You remember in the film, it was an impressively imaged in a movie, very rich halls, but on the suggestion of Paul, the McGurk Institute was named after a pickle factory in Holland, Michigan, Paul's hometown. The Heinz plant is still in full production, so is the Rockefeller Institute for Medical Research. Today I want to dwell on the last chapters of the book. The movie went over it rather shallowly. And next to Martin, there are three other characters who determined the dramatic choice he made, with which the book comes to an end. You saw them in the movie. First, there is Georgetown, Lewis's second wife, mirrored after Grace Haggard, Lewis's first wife. No, George. The second is Dr. Rippleton Holabird, as is described as a tall, slim, easy man with a trim moustache, gaily elegant, yet so distinguished, conferring instead of sweating at his laboratory bench. The director of the McGurk Institute. Holabird was designed as a combination of two doctors at the Rockefeller Institute of Medical Research and the Rockefeller Hospital. The third man was Terry Wickett, an assistant researcher, a combination of two colleagues at the Rockefeller with whom Paul had made adventurous hikes into the wild, Jack Northrop and Tom LeBlanc. I lead you through to the end. Martin returns from his expedition to control the plague on a Caribbean island and is welcomed back with much applause. He wants to continue his successful bacteriophage experiments, but Joyce advises him to relax and to join Wickett, who in the Vermont wilderness has a shack, bird's nest, that he wants to expand into a laboratory. And that without a director and trustees on his back, who would force him to write full reports to satisfy the donors. The writers did not choose this harsh spot at random, as I will reveal at the end. Back and refreshed after his outing, Martin starts studying the possibility to grow bacteriophages, as we heard, on dead bacteria. But Moorworth advises strongly to turn to influenza as a more profitable subject, as the great flu epidemic had just subsided. He wants to get into the race against the Rockefeller Institute. I always had the impression that McGurk was the Rockefeller, but now it turns out that both New York institutes were competing in research. Martin takes it on half-heartedly, and then Wicked is back in the McGurk, and wants to have quinine derivatives tested for decomposing toxic effects of bacteria. He requests a lot of monkeys for testing. Hollenberg offers $10,000 as the animals can also be used for experiments on pneumonia, a common result of influenza. But the experiments do not go as they like. Nevertheless, Hollenberg insists on publication of flattered results. Outraged, Wicked quits and is discharged. He returns to Birdie's Nest to build his own laboratory. Martin stays and returns to his bacteria pages. Joyce is pregnant and tries to get Martin accustomed to parties with other rich people who are not interested in his work. He becomes impolite and rude to his wife's friends. The baby is born, but Martin escapes again to Terry Wickett's place in Vermont for a week. He enjoys the real work and the rough living conditions. Terry tells him to choose between Joyce and him. Can't have both. Back home, Dr. Hollenberg offers Martin to become assistant director at the McGurk, with the prospect of a full directorship. Martin gets phantoms about his future. Dictating letters, taking interviews, buying lab materials, and lunching with distinguished fools. Administration and no real work anymore, like Hollenberg. He resigns, kisses his son, and says to the little one, "Come to me when you grow up, old man." Egoistically, he leaves little John to his mother and other people to bring him up. And exactly that was what Paul the Crab had just done with his two little sons and their mother. There is some prophetical in what Lewis and the Crab made Martin say to the baby boy, wishing that he eventually might look him up in the wilderness. The Crab support his sons financially, and only when they are doctors, they contact him. Meanwhile, Martin takes a train to Vermont and bobsleds to Birdie's Rest. Hello, Terry comes for the key. Terry replies, "Fine, Slim, say there's a lot of dishes that need washing." Joining Terry in the research on quinine derivatives gives him strength and enough adventures to keep living for decades. Stronger and surer, but no doubt less human. Joyce made one last effort to keep him because of their son, but she finally understands, asking, "Martin, aren't you a little insane?" And she divorces him. Martin and Terry go on. I feel as if I were really beginning to work now. This quinine stuff proves pretty good. We'll plug ahead on it for 2 or 3 years, and maybe we get something permanent. And probably will fail. Paul proposes to Lewis in vain to use possibly instead of probably. Paul is always for the upbeat and Lewis for the downbeat. In this book, in this mood, the book ends. And Martin must have recalled his prayer of a scientist when he entered the McGurk Institute. And he prays it in the movie, and I'll recite it again. God, give me unclouded eyes and freedom from hosts. God, give me the quiet and relentless anger against all pretense and all pretentious work and all work left slack and unfinished. God, give me a restlessness whereby I may neither sleep nor accept praise till my observed results equal my calculated results, or in pious glee I discover and assault my error. God, give me strength not to trust to God. The calculation had to match the expected outcome. If not, we'll try again. That was the dogma of Paul the atheist. This is their religion, science. Explore, detect, and analyze the results properly, and social context may corrupt pure research. The end of the book suggests that while working towards a solution for a human disease, the two comrades in scientific arms don't care about the usefulness. Curing is for another type of doctors. And if the end result does not fulfill the expectations, don't try other scientific goal. That's what science is about. Here's the warning. Pursuing science religiously, ignoring the world around, is a dead-end route. The two men, as hermits, odd, eccentric characters in the wilderness, detach themselves from social human contacts. And without a scientific library, money, animals, and the backing of an institute, they will get lost. A bleak future for a perished medical doctor and a biomedical researcher, no matter their scientific brilliance. I doubt whether the young people who read Arrowsmith and decided for biomedical or medical study understood this message. There is one hope in this cliffhanger. A wide view for Martin and Terry that is not revealed in the book. It came to me only when writing this presentation. By 1925, when Arrowsmith was published, there was a tuberculosis laboratory in the Adirondack Mountains, upstate New York, and indeed close to Vermont, the same climate, harsh climate. As a microbiologist, the Cruyff must have known that in 1885, a Dr. Edward Trudeau had started tuberculosis research in Saranac Lake in a shed. A strikingly similar situation. And Paul then also knew that it had meanwhile grown into a sanatorium and in a full-fledged and well-equipped research laboratory for tuberculosis. At present, it is a respected and famous institute for the study of immune responses against various infectious diseases. The Vermont Shack Laboratory of Terry Wickett and Martin Arrowsmith might have had a promising future. It was kept concealed by the authors. Some readers may have discovered it way before me, but I found no trace in the literature. my pleasure to reveal this outlook at the Centennial Arrowsmith. Thank you.
So are there any questions?
I have a comment about the ending. I was proposing that Martin Arrowsmith finds himself, goes back to be a, famous, medical professor. Where I just thought of an alternative. It was kind of like those Marvel movies where there was a post-credit scene. So what if these two guys find some brain therapeutic tool, and this really was nothing more than a startup company, like billionaires. I mean, it's possible.
But they despise that.
Pardon?
Well, they despise that because they don't, that's not the way to have monetary gain.
Well, in Canada, when they developed insulin, they refused to ban it, right?
Yeah.
So, I mean, that is a very good ethical issue.
I've got an esoteric question for Chad. What is it about Oliver that's like Robert Maynard Hutchins? He's always been a hero of mine, as the iconoclast. Is that, I'm just trying to wonder what was about him, because I felt like in the book, he's sort of I would call him a huckster like Tubbs, but he's certainly went for that kind of publicity where Maynard Hutchins seems to like revel in fighting administrations, multidisciplinary things, starting the metallurgical thing in World War II. I mean, so what is it that caught you about Hutchins in that way?
I just, a lot of the Chicago faculty saw him and his efforts as overreach. He developed this kind of, I'm not sure I would say it's hostile to the traditions of academia, but kind of hired his own, he picked who would teach in the college at Chicago, which is not how a university is supposed to work. It's more like a corporation. So, and he did it for, I think, reasons that we generally are sympathetic to. He wanted to make sure that big questions were asked at universities. And, again, I think there's a certain, I don't know, I went into my research about Hutchins finding him to be a somewhat heroic, like these were all I love the great books, concepts, things like this. And found out that actually there was a lot that he did that kind of dismantled big gains that Chicago was striving for. And so in a way, it turns out to,
perhaps shallow view, right?
Yeah.
Because he's a hero in the McCarthy years too, right? He's protecting professors even in the 30s from being fired for their political views.
right, and he's absolutely, 80% there's an absolute academic hero there, but there's these other pieces that I just started to recognize in the Arrowsmith characters that, I don't know, just kept drawing me back in. Like, there's a reason these academic traditions and institutions matter, because they fight against, even the good guys can do things to dismantle it from the inside.
He certainly wasn't adverse to publicity.
Yeah, that is also true.
What was that?
He was not averse to publicity,
Yep, he was
but it was always
a good looking dude. He was happy to be in the press, that's right.
Yeah.
I think I have a comment for JP. Your observation about the Ruby's Rest and the sanitariums up in Saranac. My great grandmother worked in one of the sanitariums.
Oh, really?
And told stories. She was one of those people that would accompany bodies back to the families, and it sounded really awful. But I just thought it was interesting that you connected what seemed to be sort of individual like research about some shack in the woods to something that was really a big deal in the 20s in terms of, the business of dealing with tuberculosis. I was wondering if you could just say a little bit more about it, because I just find that fascinating. Because the sanitariums died out, I guess, is the treatment of tuberculosis. changed.
Well, one thing is, I tried to search, Pulitzer-Prize has dealt with tuberculosis a great deal. He organized rallies in the big cities. That was not a small thing. And he wrote about it a lot. So, but then I never found any reference to Saranac Lake in his writings.
Really, it's interesting.
So it's my hypothesis.
Yeah. Coming from upstate New York, it was a big industry in the beginning of the 20th century.
With healthy air and all that, yes.
Oh, yeah.
It was still going in the 50s, wasn't it? Weren't there still?
There were some features, you read the whole idea of healthy air, and, if your lungs are infected, you breathe nice air, I guess it helps. I'm not a scientist like you guys, so.
No, in Europe they were sent up in the Alps. Yes. But they don't do that. But still, tuberculosis is not an easy infection to cure. You need a multiple approach of antibiotics. It's not so easy.
That brings me to a question I want to ask you, and that is, we hear about diseases that are resistant to antibiotics, especially in link with tuberculosis. Has anybody found a phage that will attack tuberculosis?
Oh, yeah, there are plenty, yeah. In fact, many of that library of 20,000 or so phages, a decent number can infect mycobacterium tuberculosis.
Really?
Our host is Mycobacterium stigmatis, but some have a fairly diverse host range, broad host range, and they can infect multiple species. So some phages appear to be really highly specialized, some can infect multiple species.
So they're not all just
Not necessarily just one species.
one species specific. Oh, really? So if you're devising an antidote for something, you have to put together a kind of cocktail of phages, right?
Generally, yes. A single phage doesn't work very well because the bacteria develop resistance to it very quickly. So, so usually these phage trials that have been done more recently, they have several different phages that are used. There has not been a trial specifically for TB, to my knowledge, although it's been phage therapy trial. Although it's been talked about. There are some limitations, like for instance, the TB is usually a lung infection. It can spread to other areas, but if it's a lung infection, the bacteria are often encased in tubercles, and so how do the phages get through this wall? Through this wall of white blood cells that are kind of trapping some of the bacteria. So there remains to be there are some unknowns how that would go. There are some other ideas of using phages to prevent the spread of TB. So you could give someone who has active tuberculosis phages, so as they're coughing out the bacteria, they can be infected with the phages and be rendered harmless if someone else comes into contact with them. But yeah,
Preventive treatment.
So studying phages is not an impractical thing to do. If phages are just sort of one bacterium specific, then you'd have, for everybody that got sick, you'd have to find another phage for that person. And that's very impractical. But there are ways to find phages that will attack more than one.
there are, but that's more the exception. So you're right, it is very impractical. And that's one of the reasons why it hasn't become a widespread treatment. It's worked spectacularly for a small number of people with these incurable infections, but the amount of work that goes into treating that one person is just
Hundreds of thousands of dollars.
yes. So probably the future, if phage therapy becomes widely useful without all that work that's needed behind the scenes, it would be with more likely a synthetic phage. So as we learn more about phages and the genes, most of the genes, I've mentioned all these different phages, half of the genes within the phage genome, we have no idea what they do. And so as we learn more about what these genes do, how a phage attaches to a specific host, how that specificity is developed, it's not, right now, it would be possible to make a phage. If we knew more about how that works, you could make a phage, just a custom phage for a particular infection. So that's probably the future if this becomes so.
Or you could make a phase that would help people for discussing. Oh, okay, okay.
So I just wanted to mention, the book, Perfect Predator. One, survival advantage of eating a antibiotic resistant bacterial infection, like culture, is if your wife is an epidemiologist at the University of California. So she will take you on procedures and make her doctor friends develop bacteria collection that become allied water. Very dramatic story about his life was saved by that technique.
I see another hand? Yeah.
I have a question for Dan as well. I'm just curious at what point in the semester you introduce this reading from Arrowsmith? Is this kind of helping students understand what they're going to be encountering in the lab? Is it a way for them to read against their experience they've been having in your course?
Yeah, it's at the second half of the semester of the second course. So at that point, they have isolated their own phages. They moved on to the bioinformatics part where they're looking at our genome sequences, figuring out the genes. And then that gets, the reason my rationale, because it would make sense almost to put this at the beginning, but that process gets really tedious. And so this is just a completely different thing to just kind of freshen them up. Like, let's do something completely different for a while. So that's my rationale. But from a content perspective, it would fit better with that first half of the bench work of the semester.
I've visited his classes, and I've seen the students discuss these things about what's different between Arrowsmith's research and what we do today, and they're excited. They're quite enthusiastic about this. And they get to dig up dirt and find things that nobody's ever found before. It's a terrific experience.
One little quick addition to that, so in something that we can discuss. So biology as a field, the majority of PhDs that are awarded now are for women, are to women. And so that's completely different than what we see in Arrowsmith. And most of my students, the majority are women. So they get a chance to comment on how things have changed within, at least within biology. Some of the other sciences are different. So biology
Is there any sample here and in Florida or in South America or in Europe? Can you find the same thing?
Yeah, that's been a real kind of fascinating aspect of the C-Phages program. At first it was thought there will be some geographical distinctiveness with the phage populations, but we have not seen that. It's almost the same no matter where we look. So they must be traveling around the globe with dust storms and wind, because they can't move. Phages, they can't move. It looks like they could crawl on things, but they can't. They're inert. But somehow they're spreading across the globe. And it's pretty relative. I mean, there are some slight differences, but not huge.
I have a question. A fascinating book I read when it came out 30 years ago was Full House by Steve Jacob. And he talks about that the history of life on the planet is extinction with the exception of bacteria and viruses. How do phages fit into that? Have they always been here? Have they?
Yeah, it's not known exactly, but probably. They're ancient. They probably, so with cell-based life, there's likely a common ancestor. With phages, it's a universal common ancestor. With phages, they've been with us, early bacteria for as long back as we can look. They don't fossilize well, so it's a little bit tough from that perspective, but there may have been multiple origins for phages, as opposed to cell-based life, and viruses in general, but phages were first. They're ancient, if you're ancient. There may be remnants of mobile DNA elements.
But there must have been bacteria first.
Yeah. The ancestors of bacteria, and another group called Archaea. They're a bacteria-like microbe. It's a little more closely related to humans. Bacteria kind of branched off from others.
I was just wondering, since one's reading so much about AI these days, whether that's been applied at all to phages, since there seem to be so many of them, with AI being an aid in terms of trying to sort through all this and how it helps.
Yeah, but yes, it would be. It's almost a dilemma well, I can think of two things. So there's one is protein. I mentioned most of the genes, we don't know what they do. But we know their sequences. We know where the gene starts, we know where it ends. And we can say, all right, this gene probably goes for a protein. And there's a new AI software that's really revolutionary called AlphaFold that can now take a protein amino acid sequence and fold it with almost 100% accuracy to get the three-dimensional shape of that protein. And it's just, that is a huge jump in the field of biochemistry. So so now we can have a better idea of what that gene might do. Also with this annotation stuff, this is where I feel really conflicted about the whole thing. What my students do in that second semester, I sometimes think, the AI, this seems like a perfect thing for AI to be doing instead of us. But then how will we know how it's right? Yeah, so it's coming.
I guess it seems as a tool rather than a takeover.
I have a question for Ted, and that is, this is maybe off the wall, but, and I'm sort of a devil's advocate here because I've argued for liberal arts education all my life. I taught at a liberal arts college. I like the idea of general education. But what do general ed people say about Oxford and Cambridge education? Because in Oxford and Cambridge, if you go to study, you can study medieval English or English all the way up to the Renaissance, literature from that period, and that's your undergraduate degree. And the test you take at the end of 3 years is like my PhD exam. It's exactly, even harder than my PhD exam. And that's what undergraduates do at Oxford. So, and yet, all those students at Oxford and Cambridge, they can talk about other things. They're not just sort of isolated in their little world of what they specialize. They're very widely read and well-rounded. So what do the general ed people say about that?
I think it may be a cop-out, but I think they point to high school education as what leads a student into an Oxford or Cambridge is probably stronger than what we offer here. I have no way to back that up. I just whatever. I've also heard that saying. Okay, there we go. Well, I've heard that argument also in the conversations about that there's a lot of movement toward a 3-year degree here in the States, much like Oxford and Cambridge. And it gives us the creeps because we are so used to and believe in this 4-year arc. But we say Oxford and Cambridge do it in 3 and they come out fabulously educated. Why can't we do the same thing? And it's just a parallel argument. And again, for the record, I am also, my dissertation was largely in defense of general ed. I went in search of its origins and I cared about it. And then I kept encountering this, the barbarian from the early 20th century, this the uneducated specialist figure. And so Arrowsmith just kind of turned me upside down for a moment. Like, I was like, wait a minute, I've been arguing for this thing, yet all the people we care about are somehow the villains in this novel. So it was a lot of fun.
Yeah, it's always good to see the brand being promoted. It's an excellent question, and I guess I'd be dishonest not to say there are some who wonder if people are, sort of drilling down in one subject. But I think it into what you said, to get into the university, what goes out to the Cambridge, you do have your A levels, and they can really, I mean, I could do an A level in history, but I could read, major in history, but my A levels would be French, physics and history. And I also think within Oxford, maybe it's because you're only reading one subject, I think there's a lot of curiosity, and that the student experience, is either in colleges, which are collegiate communities, and within the colleges, you have what are called common rooms. So the junior common room for undergraduates, the middle common room for graduate students, and then the senior common room for faculty. And so within that, you do have a lot of exchanges. I think that plays, and also people, I think, don't want to appear well-rounded, and I think students in this country, you don't have curiosity of a lot of things. I mean, here, we've got people studying English, we've got lawyers, we've got scientists, and so you put them all into a room and then have an exchange of ideas.
I've got a question, Ed. So the characters, specifically Hollywood, they're independent institutions, no longer really tied to an academic institution. But there's a lot of characters at the University of Winnipeg. So I'd be curious about some of those characters. My favorite is Roscoe Geek. But it's thinking all the talk about Gottlieb today, it's an English professor that draws Arrowsmith to Gottlieb by sort of romanticizing and romanticizing failure. And that's like the eccentric English professor who usually doesn't get along with. So I'm just curious if you had any thoughts on any of the early cast of characters there.
I love that observation, first of all. It may be that English professor is the English version of Gottlieb, right? They're kind of eccentric, ironically, that's trouble affiliating. No, I don't know if I have a good answer, because my sharpest memories of the early part of the book are the classmates and all of the kind of ridiculous antics and personalities there. But that also tracks in a similar way to me, those who are kind of doggedly studious, or, they're kind of outcasts, and those who are kind of goofy and, pranksters, who seem to be there for the good old college experience. They aren't the ones that come out I don't know. I'm blanking at the moment on the faculty side of the ledger.
Would Sinclair and Lewis have survived Oxford, or did Goldberg Prairie and Saxon do his magic?
We did go to Yale.
Yeah, he's
Kind of flunked out, but. No,
Oh, he graduated eventually.
And actually, he did so he graduated from high school and then did kind of, imagine like college prep school, he went to Oberlin.
Oh,
It was
two
considered-
semesters.
Yeah.
2 terms.
Probably would have survived. Right, and to get into Yale in those days, you had to pass, the diaries are just full of the tests you had to pass, and, in Greek and Latin and physics, all of the sciences, and he's more well read about everything. It's really striking. Oh, I had to pass this again, and I'm thinking, okay.
That's an argument for the elite feeder schools.
Yes, so back then, for students in Minnesota, they would come down to the Twin Cities, and there were entrance exams for like the Ivy Leagues. And so if you pass those, then they'd admit you, but if not, they'd say, you're Farmer Joe from Minnesota, so you don't get to come. And that's one of the reasons why Lewis feels kind of out of step, because most of the others are from privileged high schools, the elite prep schools, all that sort of thing. And he's kind of like Young Man Axelrod in that great story that, you know, he spent the time, he put in the work, he was different from his high school classmates, because he really wanted to learn other languages, and he was just determined to finish, but yeah, he actually did really well at Yale.
And his teachers were impressed with him.
Oh, yeah, because, well, as those of us who taught college know, many kids go to college for the socialization, for the reading, you know, for the hanging out, for the growing up. And Lewis was kind of beyond that because he'd been to Oberlin, so he really just wanted an education, which is what we really want our students to be like.
A little detail about English, Paul McCart's doctoral thesis, was turned down by an English professor at Harvard.
Really?
So he had to redo the whole thing.
Another ground, what grounds were you know?
Oh, pickiness.
Oh, very special.
The emphasis these days on STEM education, and they now added that art makes STEAM. I think it should be streaming with reading art, but the whole emphasis just is really going away from humanities, and I think that's a problem, and I'm not sure how that can be addressed at this point.
Well, speaking as somebody who did curriculum for many years, kind of like Dad, you know, it goes in great cycles. So if one's a student of curriculum, you know, you'll get a cycle of something, and then you'll get a cycle of something else. And I mean, the STEM or the STEAM is a very pragmatic approach. It's one of those where, oh, let's go back to stuff that will make money, that's practical, that's applied, that's, you know, you major in this, and your job is that, as opposed to, you know, liberal arts where you major in whatever you major in, and then you can adapt to different fields of study. So it's kind of whether it's a one-to-one preparation or not. And you know, the part of the problem with that is jobs, say 20 years from now, nobody may even have any clue as to what they are right now. And so sometimes if you train that narrowly, become a specialist, you're training yourself into something that will be obsolete in 20 years.
Some things are getting used in space. It's also been interesting with STEM, because that was a great point. You know, I mean, so much of that movement is about making sure young kids don't ignore it because it doesn't seem as fun as other things. And so it's this kind of science positive, like, oh, do this and you're at jobs and prosperity and good things are at the end of that line. As though it's somehow in competition with art things, which ironically, you get up to the next level and they're just dying on the vine because students, once they get to college, rarely, increasingly or decreasingly choose those options because they can't see the prosperous path at the end. You know, it's regrettable because it's there, they just can't see it, they don't believe it. What's strange to me is that those two are not really the story. The story is, and the data, I wish I had a graph to use, but the huge share of majors and where students are departing both science and humanities is into business. You know, like that's where they're all going. That's the future of college majors, and if you just look at the stats, they're all just dumping themselves right into that bucket. And both science and more so humanities are just getting choked.
And I'll say with my classes, at least these Phage classes, I don't have prereqs. So I will take any student who wants to. There's a real low barrier for entry. So if they are an English major, or they're a psychology major, or they're a biology major, they're all welcome to take that. Because I do see them as complementary to these skills. If you're going to be a scientist, you need to communicate.
Yes.
You need to write. So these are transferable skills, no matter what area you're in.
I mean, going back to the two cultures debate, but also
to your last slide, when you mentioned, I was thinking about science fiction, and just, it's fascinating, part of this decade that we visited in the 20s, 2 years later, so 1927 was kind of the first journal coinage of science fiction, so that's kind of happening at this time.
Yeah.
And in terms of borderline humanities versus the sciences, I was curious if there's other literature-related literature you've also found helpful or inspiration.
Well, let's see. So, I've really enjoyed, well, this isn't a literature one. So that Cubes resource we used, we had some old literature on bacillus, bacteria, not so much fiction, but it's encouraging students to get outside of just like, all right, this is what we know right now. Let's look at something. It was written long ago to a different audience, so that's another approach that I could take. Sometimes in my class to look at, let's go look at something that would be considered old. And sometimes their definition of what's old is 10, 20 years ago, but we're talking about this state of the art sort of things back 100 years ago. So that's one approach. You're putting me on the spot here.
No, that's right.
I will think of, I always go back to like The Perfect Predator or but that's not fiction though. I do like a lot of popular science type sorts of things. But that, yeah. I'll get back to you.
No, I was just, and then the flippers, when you're talking about that, in terms of noticing multiple texts from the area, actually talking about, regardless of general specialization, the whole focus on business that's happening at the time too, and trying to figure out what that type of debate was at that time with this kind of instrumentalization of education that is very present.
Yeah, I don't think business had that much of a presence in Northern Ireland yet.
Yeah.
It's coming, but yeah, once they arrived, it completely changed the choices in the demographic.
The choice.
Yeah. I had one last, or I don't know if it's last, but I had a question for Dan too. And may I just ask you about, you mentioned something about you can't patent a single phage because it just occurs in nature. So I may not have read them with enough nuance of what were they trying to do at the institute? Was it I know you can't patent a tree or right? I mean that's in nature. So I get it that you can't patent a virus. Is what they were going for then more like a process, or is it the cocktail that's unique?
I guess when I mentioned that, I was more thinking of today, not so much an issue with anything that occurred in the novel. But it's just a lack of incentive for commercialization of these products. I'm trying to think back to the book if that was ever discussed, and I don't recall that.
I guess I was just thinking of the pressure that they felt to like publish quickly. Maybe it was just about notoriety for the institute, but it also seems like there was some profit motive that was in there that may have been about.
Yes.
But then I
And so yes, so yeah, they were talking about making a concoction that could be sold and expanded, and that has been done historically. There were phage products that you could buy at the drugstore, and you can still in some parts of the world. And there are some products sold in the United States that are phage products that are commercialized. But there's not really much stopping someone else from swooping in and doing the same thing, because you didn't invent this. This was harvested from nature. Although that might be changing as we go in the future. You could make proprietary novel synthetic phage that you might. I don't know the ins and outs of patent law, but that you might be able to patent that. In that last phage therapy example I gave, that was a genetically altered phage, but they were able to get around regulations by just removing genes instead of actually adding something. So, but I still don't think that could be. And the reason why they did that is it forced the phage to go into that lytic cycle and kill the host instead of going into that other cycle where the host doesn't necessarily die. They removed a gene that controls that switch.
This reminds me of a question that I've probably asked you before, and that is, you've told me that when your students identify these phages, they get sent to what you call a library of phages at the University of Pittsburgh. So what gets sent in? Just the description, the DNA description of it, or the actual
physical,
material?
the phage particles.
The actual particles get sent in.
How do you get them to Pittsburgh?
Dry ice. Yeah, we put them in a cryopreservative that prevents, it's called DMSO. We mix it with the buffer that the phage are in, and it prevents ice crystals from too aggressively impacting the phages. And then we put them in a particular box and top of dry ice and overnight ship it. And they have a massive library of these phages.
So what happens if the power goes out?
Well, so we save them at our institutions. So we split it up. I have them stored, and all the other institutions that have it, because that has happened. Not to them, but I've been involved in the top institutions where you start sweating.
They must have generators.
They have battery backup.
I do have one burning question. Are any of the phages named after Arrowsmith or any of the characters?
No.
Yes.
I will look it up right now. You can give me, because I have a whole list, but I don't think there are.
Well,
But
It's time.
That Aerosmith.
Yeah.